Hello friends, in this session we will discuss the subject thermodynamics for your CIL point of view. We will cover only those topics which are not included in that 2 hours video of the thermodynamics. So you have to watch that 2 hours video also along with this video. In this I only covered that part and mainly the theory part which are not covered in that previous videos. So first of all, let us see what are the types of system in the thermodynamics. There are 3 types of system: open system, closed system and your isolated system. In the closed system, only there is no mass transfer in the closed system, only energy transfer can take place. In the open system, both mass and energy transfer can take place inside the system, and for isolated system, no mass and no energy transfer will take place. So there are 3 types of the system. Next is the property of a system. If we say what is the property, properties are those characteristics of a system by which you can define the state of a system, right? Property वो चीजें होती हैं, वो characteristic है आपके system का जिससे आप system के एक state को define करते हैं. So properties are of 2 types. One is the intensive property and one is the extensive property. Intensive properties are independent of mass, right? So you can learn by this. Intensive means independent of mass, which are not depending upon the mass of the system. System के mass पे depend नहीं करेगा. For example, your pressure, density, thermal conductivity, your viscosity, temperature. These all are the intensive properties, right? Next is the extensive property. Extensive properties are dependent on mass, जो कि आपके mass पे depend करेगा. So example of extensive property are your volume, your internal energy, enthalpy, entropy, right? These are not specific, right? You can write as internal energy, enthalpy, entropy. These are the extensive properties, and ratio of 2 extensive properties are the intensive property, right? So 2 extensive property ratio will be your intensive property, and there is a term called specific properties. Specific properties are extensive property per unit mass, and that is also a intensive property, just like your specific volume, specific internal energy, specific entropy. Those are the intensive property, that is extensive property divided by mass. So if we say what are the important points with respect to property, properties are a point function, not a path function. Properties of a system will depend upon the state of the system. If that state is fixed, then that property of that system will be fixed. They are not depending upon the path, right? If the system or the system is going from point 1 to point 2 via some path, कोई एक path follow किया है उसने, but properties are depending upon the initial and final state or on that state, and it do not depend upon your past history कि आप उस state पे कैसे पहुंचे हो. That is not the property will not depend upon the past history, and properties are the exact differential. So these are the 3 important points with respect to property. Next is your Gibbs phase rule. Gibbs phase rule is P plus F is equal to C plus 2, where P is the number of phase present in that system, F is the degree of freedom, C is the number of component present in the system. So degree of freedom क्या बताता है? Degree of freedom tells you the number of minimum independent intensive properties which are required to define the state of a system. आपको अगर किसी सिस्टम का स्टेट डिफाइन करना है, देन आपको कितना मिनिमम नंबर ऑफ इंटेंसिव इंडिपेंडेंट प्रॉपर्टीज चाहिए, दैट इज द डिग्री ऑफ फ्रीडम. यू कैन सी दैट किसी भी स्टेट, किसी भी सिस्टम का अंदर नंबर ऑफ प्रॉपर्टीज आर देयर. बहुत सारी प्रॉपर्टीज होती हैं, प्रेशर, वॉल्यूम, टेम्परेचर, एंट्रोपी, एंथैल्पी, बहुत सारी प्रॉपर्टीज होती हैं. लेकिन आपको मिनिमम कितना प्रॉपर्टी चाहिए कि आप उस स्टेट को डिफाइन कर सकें, देन दैट इज द डिग्री ऑफ फ्रीडम. And degree of freedom of triple point is 0. Triple point is a fixed point. Triple point क्या होता है? Triple point is that point where all the 3 phases, that is solid, liquid and gas, can coexist in equilibrium. उस point पे तीनों phase आपके present रह सकते हैं. That is the triple point, and triple point is a fixed point, so its degree of freedom is 0. And triple point of critical point right? Or you can say, sorry, degree of freedom at critical point. Critical point क्या होता है? Critical point is that point where liquid will directly flashes into vapor without taking any latent heat, right? You know that for the phase change you required some latent heat. आपको कुछ latent heat चाहिए, but at critical point your latent heat will be zero. That means at that point your liquid will directly flashes into the vapor. So degree of freedom at critical point is not defined. Why? Because at critical point your phase is not defined, whether it is in liquid state or in vapor state, we don't know. So degree of freedom at critical point is not defined, right? If we will say what is a reversible and irreversible process, reversible process is that process, suppose if a system is going from point 1 to point 2 via a process A, so if you reverse the process, right, reversible process is that process, if you reverse a process, then there should not be any net effect on system and surrounding. That means system and surrounding will come back to its initial state. अगर आप किसी भी प्रोसेस को रिवर्स करते हैं, आप उसको रिवर्स डायरेक्शन में लेके जाते हैं from 2 to 1, then there should not be any net effect on system and surrounding. That means system and surrounding will be back to its initial state, and you know that for a reversible process your entropy generation will be zero, right? There should not be any change in the entropy of system plus entropy of surrounding. Now if we want to find what is the points regarding to work transfer and heat transfer, right? Work and heat transfer we already discussed in our earlier videos, the various work transfer for various processes, heat transfer for various processes. If we see what is the points regarding your work and heat transfer are, your work and heat transfer are the boundary phenomena. Boundary phenomena means that if you said that this system is doing some work or some work is doing on the system, then the work or the heat shall cross the boundary, right? If the work and heat is not crossing the boundary, then you cannot say that work or heat is done, work or heat is transferred, right? So boundary must be crossed by the work or the heat. If you say that if a system is there, inside it some heat transfer is there, let us say, if I say that, if let us say this is a system, at this point temperature is 100 degrees Celsius, at this point temperature is 50 degrees Celsius, so from here heat is transferred to 50 degrees Celsius, but this is inside the system, this process is occurring inside the system, so we cannot say that heat is transferred. For the heat or work is to be transferred, this boundary shall cross, so it is a boundary phenomena. And heat and work transfer are the path functions. Path functions means that work and heat transfer will depend upon the path followed by that process. उस प्रोसेस ने कैसा पाथ फॉलो किया है, इस पे आपका वर्क और हीट ट्रांसफर डिपेंड करता है. एंड इफ इट डिपेंड्स अपॉन द पाथ फंक्शन, देन it depends upon the past history, right? Your work transfer will depend upon the past history, how you will reach to that state, and it is not an exact differential. वो एक exact differential नहीं होगा. Our next topic of discussion is that why Cp is greater than Cv, right? Why your specific heat at constant pressure is greater than specific heat at constant volume. Objective question आपको मिल सकता है एक CIL में. So in your that if you give some heat to a system and if you are maintaining the constant volume, constant, let us say a piston cylinder arrangement is there and that piston cylinder arrangement is fixed, it cannot move, so that you can maintain a constant volume inside the cylinder. So the amount of heat you are giving to the system, that heat will directly converting into the internal energy of the system and it will increase the temperature, right? आपने जो heat दिया constant volume पे, वो directly आपका internal energy में convert हो जाएगा और उसका temperature increase कर देगा. While if we are saying that we are maintaining a constant pressure, so let us say that same piston cylinder arrangement, to maintain the constant pressure, if you are giving some heat, then inside the pressure will increase. So to maintain the constant pressure, the piston will move upward. Piston को थोड़ा ऊपर move करना पड़ेगा. So if piston is moving in the upward direction, that means some work is done on the piston. Piston को ऊपर move करने के लिए आपको कुछ work देना पड़ेगा. So if the amount of heat you are giving to that system, the part of that heat, some part of that heat will be consumed in moving the piston. Piston को move करने में कुछ work consume कर जाएगा, and remaining part of heat will be converting into the internal energy. Right. So if you want to increase the same temperature of the gas as of the constant volume process, then you have to give more heat to the system. Then we can say that your Cp is greater than Cv. So in constant pressure, the amount of heat which you are giving is partly consumed by the piston as the piston is moving, and partly consumed or converted into the internal energy of the system. That's why Cp is greater than Cv. If we are talking about the throttling process, what is a throttling process? Throttling process is a process if the fluid or any gas is flowing through a partially opened valve or small orifice. अगर कोई भी फ्लूइड आपका पार्शियली ओपन वॉल से फ्लो करता है, एक स्मॉल ऑरिफिस से फ्लो करता है, देन दैट प्रोसेस इज नोन एज थ्रॉटलिंग प्रोसेस. एंड द कैरेक्टरिस्टिक्स ऑफ द थ्रॉटलिंग प्रोसेस आर, वी कैन से दैट देयर शुड नॉट बी एनी हीट एंड वर्क ट्रांसफर इन द थ्रॉटलिंग प्रोसेस. थ्रॉटलिंग प्रोसेस के अंदर देयर शुड नॉट बी एनी हीट और वर्क ट्रांसफर. एंड थ्रॉटलिंग प्रोसेस इज ए इरिवर्सिबल प्रोसेस. थ्रॉटलिंग प्रोसेस आपका एक हाईली इरिवर्सिबल प्रोसेस होता है. एंड थ्रॉटलिंग प्रोसेस इज एन आइसेंथैल्पिक प्रोसेस. आइसेंथैल्पिक प्रोसेस मींस द एंथैल्पी ऑफ द योर थ्रॉटलिंग प्रोसेस विल बी कांस्टेंट. एंथैल्पी आपका कांस्टेंट रहेगा, सो इट इज नोन एज योर थ्रॉटलिंग प्रोसेस. If we will talk about the second law of thermodynamics, zeroth law of thermodynamics will give us the definition of your thermal equilibrium. We can say that if a body A and body B are in thermal equilibrium, that means their temperature is same. If body B and body C are in thermal equilibrium, so we can say that this body A and body C will be in thermal equilibrium. Right? This is the concept of your zeroth law of thermodynamics, and on this basis we will develop a device known as thermometer. Right? There are various types of thermometer, we already discussed. Now, and first law of thermodynamics says that energy can neither be created nor be destroyed, it is conserved. Right? So we can say in a cycle the net amount of heat transfer will be equal to net amount of work transfer. We already discussed all of them. Now let us say the second law of thermodynamics. Second law of thermodynamics says that in the second law of thermodynamics we will find out that the complete conversion of low grade energy into high grade energy is not possible. Right? In a cycle, if you give some low grade energy to the cycle, then it cannot be completely converted into the high grade energy. Low grade energy is heat and high grade energy is work. Work is like kinetic energy, potential energy, electrical energy. These all are the high grade energy. So the heat cannot be completely converted into work in a cycle. That is the meaning of second law of thermodynamics. Right? High grade energy can be completely converted into work. You can completely convert any kinetic energy into heat. Complete conversion is possible, but reverse is not true, that a low grade energy can be completely converted into high grade energy. It is not possible. We have two statements of the second law of thermodynamics. First one is the Kelvin-Planck statement and second one is the Clausius statement. If we talk about the Kelvin-Planck statement says that there should not be any device which will develop a network or network output if that device is interacting between a single temperature reservoir. एक कोई भी अगर आपका cyclic device है, let us say heat engine, so heat engine cannot produce a continuous work cannot be cannot be produced by the heat engine if that heat engine is working between a single temperature reservoir. That means for a heat engine to be work, there should be minimum 2 temperature reservoirs, 2 temperature reservoirs होने चाहिए. One is at high temperature, one is at low temperature. In between that only your heat engine will work. Right, this will give the concept of your PMM2, and we can say that no cycle, whether it will be reversible, irreversible, no cycle, no device has the 100% of efficiency. It is not possible. So from the Kelvin-Planck statement we will get your heat engine concept, and second statement is the Clausius statement. Clausius statement says that if you want to transfer the heat from low temperature body to high temperature body, अगर आपको low temperature body से high temperature body पे heat transfer करना है, then you have to give some external work to the cycle. आपको उस cycle को कुछ external work देना पड़ेगा. Without consuming any external work, you cannot transfer heat from low temperature body to high temperature body. And from Clausius statement we will get the concept of your heat pump and refrigerator. Right. So this is the second law of thermodynamics statements. Next is your Carnots theorem. Carnots theorem says that for various cycles operating between the same temperature limit, if there is a temperature limit, let us say one reservoir is at 100 degrees Celsius, one is at 50 degrees Celsius. If you operate a number of cycle between them, then no cycle has the efficiency greater than the reversible cycle. अगर आपके पास एक temperature limit है, let us say 150 degrees Celsius, if you operate 2 cycles in between that, one is reversible and one is irreversible, then between the same temperature limit, the efficiency of a reversible cycle is always greater than the efficiency of an irreversible cycle, and efficiency of all the reversible cycles are equal if they are working between the same temperature limit. If you have a same temperature limit, let us say 100 degrees Celsius and 50 degrees Celsius, and if you are operating a number of reversible cycle in that, so the efficiency of all the reversible cycle will be same. That means the reversible cycle efficiency is independent of the working fluid. Right, आपका जो reversible cycle का efficiency होता है, it is not depending upon the working fluid. आपका fluid कैसा है, petrol है, diesel है, air, gas, anything it will be, but it is not depending upon your working fluid. It only depends on the temperature limits. Right, it only depends upon the temperature limit. If the temperature limits are same, then the efficiency of all the reversible cycle will be same. And we know that the reversible adiabatic process is an isentropic process. Isentropic process means entropy is constant. Right? A reversible adiabatic process is an isentropic process, but the reverse is not true, that all the isentropic process may be reversible adiabatic, may be irreversible adiabatic or irreversible process. Isentropic process may be reversible, may be irreversible. It all depends upon the heat transfer and the entropy generation. But a reversible adiabatic process is always an isentropic process. एक reversible adiabatic process हमेशा आपका isentropic होगा, but an isentropic process may be reversible, may not be reversible. And if we talk about the principle of increase of entropy, the principle of increase of entropy says that the entropy change of universe or the entropy change of an isolated system is always greater than equal to 0. Right? The entropy of a universe can never decrease. It will never decrease. It will remain either constant if all the process inside that isolated system is reversible. अगर अंदर जो भी प्रोसेस हो रहा है सिस्टम के अंदर, अगर वो सारे प्रोसेस रिवर्सिबल है देन द एंट्रोपी विल रिमेन कांस्टेंट. इफ द प्रोसेस इज इरिवर्सिबल देन एंट्रोपी विल इंक्रीज. देयर शुड नॉट बी एनी केस दैट द एंट्रोपी ऑफ द यूनिवर्स विल डिक्रीज. इट इज नॉट पॉसिबल. सो वी कैन से दैट द एंट्रोपी ऑफ एन एडियाबैटिक प्रोसेस कैन नेवर डिक्रीज. एक एडियाबैटिक प्रोसेस का एंट्रोपी कभी भी डिक्रीज नहीं करेगा. इट विल आइदर रिमेन कांस्टेंट इफ द प्रोसेस इज रिवर्सिबल, एंड इफ द प्रोसेस इज इरिवर्सिबल देन इट विल ऑलवेज इंक्रीज. देयर शुड नॉट बी एनी केस दैट द एंट्रोपी ऑफ एन एडियाबैटिक प्रोसेस डिक्रीजेस. So this is the theory of your thermodynamics. Just go through it, and I again said that those 3 hours, those 2 hours video of thermodynamics is must if you are preparing for the Coal India Limited, because we covered in that all the formulas, how to solve the numericals, various assumptions of thermodynamics. The next topic of our discussion is your thermodynamic relations. Let us see some of the important equations in the thermodynamic relations. Let us say first of all our equation is the Maxwell equations. There are 4 Maxwell equations in the thermodynamics. First one is your del T by del V at constant entropy will be equal to minus of del P by del S at constant volume. I'll just read out all the 4 equations. Second one is del T by del P at constant entropy will be equal to del V by del S at constant pressure. Third is del V by del T at constant pressure will be equal to minus of del S by del P at constant temperature. And the fourth one is del P by del T at constant volume will be equal to del S by del V at constant temperature. So you may find that these equations are very difficult to learn in this form. So let us see how to learn these equations. So you have to write this Tapasvi method. We will learn it with the help of this Tapasvi, that TPSV. Let us see how to remember it. So if I start from here, I reach here in this direction, right? If I start from here, then I reach in this direction. So if this is the case, so we can write in this vertical, we can write del T by del P at constant entropy. Del T by del P at constant entropy will be equal to, this one is del V by del S at constant pressure. Del V by del S at constant pressure, right? This equation is this one. So just remember one thing, if you end with the vertical line then take the positive, if you end with the horizontal line then take the negative. So this is like this. Now if second equation we get is, if I start from here, I'll reach here in this direction, if in this direction. So I can write del T by del V at constant entropy will be equal to this one, del P by del S at constant volume. Del P by del S at constant volume, and we end with the horizontal, so we have to take minus. So this is del T by del V at constant entropy will be equal to minus del P by del S at constant volume, right? ऐसे आप निकाल सकते हैं कोई भी इक्वेशन. ये याद रखने की जरूरत नहीं है, ये मेथड याद रखेंगे आप इजीली फाइंड आउट कर सकते हैं. Next is our TDS equations. The first TDS equation is, you know the TDS equation, TDS is equal to du. We know the TDS equation, TDS is equal to du plus PdV, right? And in the differential form this equation will be equal to TDS is equal to Cv dt plus T into del P by del T at constant volume into dV. याद रखेंगे that TDS is equal to Cv dt plus T into del P by del T at constant volume into dV. So if you write at constant volume, your dV will be equal to 0. That means TDS will be equal to Cv dt, which is equal to dq, right? So dq is equal to Cv dt for constant volume, we know that, right? So this is the first TDS equation. Second TDS equation is TDS is equal to Cp dt minus T into del V by del T at constant pressure into dP. You know that second TDS equation is TDS is equal to dH minus VdP. right? For constant pressure, you can say dP will be equal to 0. That means TdS, which is equal to heat transfer, which is equal to Cp dt. This is for constant pressure process if the pressure is constant. You may learn this equation that TdS is equal to Cv dt plus T into del P by del T at constant volume into dV, and TdS is equal to Cp dt minus T into del V by del T at constant pressure into dP. Next is our coefficient of volume expensivity, that is beta. Coefficient of volume expensivity is beta is equal to 1 upon volume into del V by del T into at constant pressure. You have to learn this, del V by del T at constant pressure, and isothermal compressibility will be equal to minus of 1 by V into del V by del P at constant temperature, right? Del V by del P at constant temperature. ये याद रखने दो, डायरेक्ट क्वेश्चन आएगा. Next is the Mayer's equations. Mayer's equation will be equal to Cp minus Cv, which is equal to Tv beta square upon Kt. Beta is your volume expensivity and Kt is your isothermal compressibility, and this will be equal to R. This form is equal to R. Tv beta square upon Kt. If I can write the energy equation you can write as du is equal to Cv dt plus T into del P by del T at constant volume minus pressure into dV. This is the energy equation. For an ideal gas, we can write that del P by del T at constant volume will be equal to P by T. So you can write from here du is equal to Cv dt. We know that for an ideal gas, du can be written as Cv dt. It means that the important concept which I want to show you here, that the internal energy of an ideal gas does not change even if the volume is changing. अगर आपका वॉल्यूम चेंज कर रहा है, this dV is not equal to 0, then also your internal energy of an ideal gas will not change if the temperature is not changing, right? So the internal energy of an ideal gas is only a function of temperature. That's why I told you in our earlier discussions that the internal energy and the enthalpy of an ideal gas is a function of temperature only, right? Because for an ideal gas this term is 0. So if dV is 0 or dV is positive, it doesn't matter. वह आप matter नहीं करता है. तो internal energy of an ideal gas is a function of temperature. If this temperature change, then only internal energy will change. Otherwise, internal energy will not change of an ideal gas. Next is a Joule-Thomson coefficient that is used in your throttling process or your isenthalpic process. Joule-Thomson coefficient is mu. Mu will be equal to del T upon del P at constant enthalpy. Del T upon del P at constant enthalpy. If this mu is greater than 0, we can say your gas will be cooled down, cooling region. If the mu is less than 0, then it may be cooling or it may be heating. अगर पेपर में आता है तो आप टिक करेंगे heating, right? पेपर में आपको ऑप्शन देगा वो heating region. If mu is less than 0, right, when we will study this in detail, thermodynamic relation, then I'll show you how that mu less than 0 can be a cooling or can be a heating. But for the exam purpose, you just remember this thing, that if mu is less than 0, then it is a heating region. If mu is greater than 0, it is a cooling region. So we can say that if you solve for it, that del T by del P at constant enthalpy will be equal to 1 upon Cp. ये याद रखना है, 1 upon Cp into temperature into del V by del T at constant pressure minus V, right? If you will see that for an ideal gas, the value of this mu will be equal to 0. Mu will be equal to 0. That means your del T by del P will be equal to 0. That means your temperature is not changing. So this is the important concept, that during throttling process of an ideal gas, your temperature will remain constant. During the throttling process of an ideal gas, your temperature will remain constant. Next is your Clausius-Clapeyron equation. For the phase change, we are saying that dP by dt will be equal to HFG, that is the latent heat, upon T saturation into Vg minus Vf. Vg minus Vf. Vg is specific volume of vapor minus specific volume of liquid. And for the incompressible fluid, we can say that dP by dt, because for an incompressible fluid Vg is very greater than Vf, so we can write that dP by dt will be equal to P into HFG upon R into T saturation square. This is the thermodynamic relation for the thermodynamics. अगर यहाँ से कोई क्वेश्चन आता है अगर आपका CIL में, then that will be on your Joule-Thomson coefficient. Joule-Thomson coefficient को एक बार पढ़ लेंगे, अदरवाइज डायरेक्ट ये इक्वेशन से क्वेश्चन आने के चांसेस बहुत कम है.